Hi friends! In this video I will guide you through using Liquibase with Spring Boot and Maven. Liquibase is the database migration tool for evolving the database schema using YAML, SQL, JSON or XML formats. It can be used to run migrations at application start, in CI, from the command line and in a Docker container. We will mix theory and practice, and I will explain the key concepts on the fly. Let's start with creating the project. We will build a crude application called NeuroWatch. It's kinda like Spring Pet Clinic, but instead of pets we have implants, and instead of owners we have civilians. Yep, cyberpunk themed, just as I like it. For this tutorial you will need Java 24. You can use any distribution that you like. As we are building a Spring Boot project, I'm using Liberica JDK recommended by Spring. You will also need Docker because we are going to spin up a database instance via Docker Compose. Create a new Spring Boot project, choose Java 24, Maven, the latest stable Spring Boot version, and add the following dependencies: PostgreSQL driver, Liquibase migration, Docker Compose, and Spring Data JPA. First thing first, we need to create some foundation for performing database migrations. Let's start with creating some entities. We are going to have 3 entities: Civilian, Cyberware, and ImplantSession. ImplantSession is going to link civilians to the cyberware that was implanted into them. First, Civilian. Annotate it with entity and table and add several fields like ID, legal name, national ID, birthday, criminal record, under surveillance, and the list of implant sessions. I don't use Lombok, so in this case I need to add getters, setters, constructors, hash code, and equals manually. I'm not showing these methods here, just for brevity's sake. The next entity is Cyberware, also annotated with entity and table. It will have ID, name, type, version, serial number, and the list of implant sessions. And finally, we have the implant session. It has the ID, the civilian mapped with many-to-one, and cyberware object also mapped with many-to-one. Next, we need repositories for these entities. They are super simple. We are not going to build anything complex here because that's not the aim of the video. So we have the civilian repository, cyberware repository, and ImplantSession repository, and they all extend JPA repository. Finally, let's create the civilian service, annotate it with service, and wire up the civilian repository into it. And just one method, find all civilians, just for simplicity's sake. This is not a web application, so we are going to add a CommandLineRunner so that our application actually does something. Let's head to the main class and make it implement CommandLineRunner. Wire up the civilian service here and add the run method that is overridden from the CommandLineRunner. In this method, we are going to simply print out all the civilians that are in our database. That's pretty much it. The next step is to enable the database connection. We added PostgreSQL to this application, so we are going to work with that. You can spin up the local Postgres instance, but I prefer working with databases through Docker containers. For that purpose, I'm going to write a compose file. Let's see what it contains. It's also super simple. We are just pulling the image called Postgres latest, of course latest for the sake of the demo, the name of the container, the environment variables necessary for accessing the database, Postgres user, password, DB, and also we specify the ports for Postgres, which are by default 5432. We also need a volume to save the data so as not to lose it if the container is removed or stopped. Finally, let's add the network. Alright, let's go to application properties and add the database configuration there with URL, which is localhost username, password, and the PostgreSQL driver. Alright, that's set. Now we can perform some migrations. We are not going to write a file with a schema or sample data because we will use migration tool for that. Liquibase has a specific architecture. The Liquibase workflow is based on several key concepts. So we introduce our changes into the changelog. Changelog is the file that contains all required changes to the database schema. These database changes are called changesets. The best practice is to have one change set per changelog. In the case we need to perform the rollback, it will be easier to do. Each change set contains a change type. These are the types of changes that are going to be applied to the database. For instance, adding a column. So the hierarchy is the following from top to bottom. Changelog is the file that contains a change set, and the change set includes one or several change types. Let's write our first changelog, and actually this is going to be the changelog of all changelogs, and we are going to call it master. Very original, right? This changelog contains only the links to other changelogs that actually contain some changes. So it doesn't contain any change sets, only the links to the changelogs. Each time you create a new changelog, you add a link to the master changelog. Liquibase will read this file automatically because we are going to point to the master changelog in the application properties file. So let's start with application properties. We need to add several more options. First of all, we need to disable Hibernate because now the Liquibase will manage the schema. So set Spring JPA Hibernate DDL auto to none. Also, you can add Spring JPA show SQL true to get more info about what's going on under the hood. Now we are adding two options for Liquibase: Spring Liquibase enable true and Spring Liquibase changelog. And here we point to our master changelog. Class path db changelog, and let's call it db.changelog-master.yaml. Because we added the Liquibase at the project initialization stage, Spring already created for us the directories db and changelog under resources. However, if you are starting with your own project and you added the dependency for Liquibase manually, you have to create these directories. So go to resources, create directory db, and inside create the directory changelog. In this changelog subdirectory, create a file called db.changelog-master.yaml. Now, I'm going to write changelogs in YAML format, which is database agnostic. I understand completely if you don't want to use YAML. Luckily, with Liquibase, you can write changelogs in SQL, JSON, or XML also. A bit later, I will show you how to do that with SQL. So, open the db-changelog-master YAML file, add the database changelog line, which identifies the file as the changelog. Now we are going to include our first changelog file here, so we need to add include file and then point to the file from the source directory. Let's call it 001-create-tables.yaml. Alright, this changelog is going to contain the logic for creating the database schema. And now let's create this exact file called 001 and populate it with some data. Right, so we have a pretty simple setup with the entities with some columns. So we are specifying database changelog again, and here we are specifying the change set. The change set contains the ID and author. It may also contain preconditions. I will explain to you later what preconditions are. Well, but the most essential part is the ID. Okay, so change set. And then this change set contains changes, and here we add change types. So the first change type is create table, and we are just specifying everything that we need. So table name, columns, and then we specify each column, the name, its type, constraints, if any, and so on and so forth. And then the same thing goes for Cyberware. So again, we need to specify the same change type, create table, but here the table name is going to be Cyberware, and we are adding the columns to the Cyberware table. And then, as you already guessed, again, create table, change type, table name ImplantSession, and add the necessary fields. Okay, the next change type we need is add foreign key constraint, right? Because we have some many-to-one relations in our database. So add foreign key constraints, base table name ImplantSession, base column names civilian ID, reference table name civilian, reference column ID, and constraint name FK civilian. This is how we tie ImplantSession to a civilian. And again, the same change type, add foreign key constraint, and let's do the same for Cyberware. So let's tie the ImplantSession to Cyberware. I promised to show you how to create the same change set, but in SQL. So here it is. I'm not going to add the file to the project, but we can look at it right now. Basically, as we use Postgres, the syntax is Postgres specific. And that's the familiar workflow that we love. The only thing you need to add is just 2 lines in the beginning of the document. _Liquibase formatted SQL and _changeset and the ID of the changeset and its author. So _changeset cyberjar 001 in this case. The first line is super important because we are actually showing the Liquibase that this is the changelog and it should treat it as the changelog, but it is in the SQL format. And the rest of the file is nothing new, right? So we are creating some tables, just like we do that with Postgres. Let's create a second changelog to insert some sample data. Go to changelog master file and insert a new link to the file called 002-insert-sample-data.yaml and create this file. In this file, again, add database changelog. The changeset ID is going to be 002, and here we'll have the certain changes like insert into table name civilian and some data, and then again insert to Cyberware and insert to ImplantSession. Here is the structure of our project. So here's the resources directory, DB, changelog, and the changelogs that we created. Okay, I think it's time to test it. Make sure that the Docker is up and running and run docker compose up -d to spin up the Postgres. After that, simply run the application. After the successful run of the application, you will see the following log in the console. Let's look at it. So we're creating database history table with name database changelog. I will explain a bit later what it is. Acquire the changelog the deployment ID. We're running the change set. Number 1, create tables. And so we created the table successfully, added foreign key constraints. And then we are running the change set number 2, and we inserted some data. And here's the update summary. So we have run 2 changelogs. Total change sets are 2. And the rest is the typical Spring Boot log. Here you can see the output of our CommandLineRunner. The database schema was successfully created and populated with data because we can see that the application found in the database the civilian that we inserted. I'm using dbeaver to connect to the database running in a Docker container. Here I have the database NeuroWatchDB, and we can see that the NeuroWatch database was created. And here are the tables: civilian, Cyberware, ImplantSession, and please note these 2 tables that were created automatically: database changelog and database changeloglock. So database changelog is the table that includes the history of all change sets applied by Liquibase. So each time you run the application, it checks first whether it has already run this migration in this table. If it did, then it's not going to run this migration. And database changelog is also very important. It helps Liquibase to acquire the changelog lock, which means that no other Liquibase instance can work with this database at this moment. So now, if you run the application again, you will see that the update summary contains the information about all change sets, but the run change sets are 0. So database is up to date, no change sets to execute, and so we have previously run 2 change sets, and that's all. So you can be sure that the change sets won't be run twice. Let's now see how we can update the schema using Liquibase. Let's add a new column to the Cyberware entity. For example, manufacturer. Now we need to create a new changelog file and include it into the master changelog. There's going to be a new entry, include file, and the path to the file. Let's name it 003-add-manufacturer.yaml. Create this file, go to this file, add database changelog line, change set ID 003, and the changes, right? And the only change type we have here is add column. The table name, Cyberware, so where we're adding this column, the name, the type, and the default value. Okay, let's run the application again. We can see here that the change set with the ID 003 was run and the column was created. Another interesting thing that you can see here is that after the update, the changelog was successfully released. Let's look into our schema, go to the database tool that you're using, refresh the database, and you can see that the Cyberware table now has the manufacturer column. Let's now look at how we can use preconditions in our changelogs. Preconditions are special tags that we can add to the changelog in general or to specific change set. In these preconditions, we specify requirements for the change sets, and if the precondition fails, then the change set is not going to be deployed. You can use preconditions for various use cases. For instance, you want to check whether the changes are applied to a specific database or by a specific user. Or, for instance, if you are trying to add some data or new columns to your database, then you can check first whether this data or columns already exist. You can add multiple preconditions by using and, or, and not tags. Also, you can perform various actions if the precondition fails. There are precondition failures, which mean that the precondition has failed, and there are precondition errors, meaning that there were some exceptions thrown during the execution of the check. So you can specify what to do in the case of the error or the failure. For instance, in the case of failure, you can say continue. In this case, Liquibase skips this change set but continues with the execution of the changelog. And it will try to execute this change set again during the next migration. You can say hold, so the Liquibase is going to hold the execution of the whole changelog. You can say mark run. In this case, Liquibase skips this change set, continues with the changelog, but marks this change set as run and is not going to attempt to execute it again on the next migration. You can also say warn, so the Liquibase is going to continue executing this change set and the changelog, but is going to send a warning to the user. Let's implement the precondition in practice. I'm going to add a new file just to make it more clear. But of course, preconditions can be used with any changelog, whether you create a database schema, populate it with sample data, or update the schema. Right, I have created a new changelog file 004-test-preconditions. Okay, specify the line database changelog, change set, give the ID, and here the precondition. We are going to say that if there is a failure, mark this change set as run. So on fail, mark run. And then we are specifying that if the column exists in the table Cyberware named type, don't implement this change set. So not column exists, table name and column name type. And then the changes that we want to implement, let's try to add a column to Cyberware named type. We know that we already have the field type, so let's see what happens. Okay, run the application. You can see in the console log that there are total change sets of 4. We added a new one. And you can see the error. There's the exception that the column already exists, so the precondition failed, the check has failed, and the application didn't run because the check has failed, and we could not update the database. And here you can see the stack trace of the exception. If you try to run the application again, it will run as usual because this change set will not be attempted again by the Liquibase. Another important feature of Liquibase is rollbacks. Suppose that something goes wrong and the changes that you have introduced brought more issues than you have expected. Liquibase offers the functionality of performing rollbacks. Rollback commands revert deployed database changes. You can configure the rollback category. For instance, there are simple rollbacks that revert the changes based on the changeset tag. There's also the RollBaseSQL. This one is going to be run before the actual rollback command to inspect the SQL that's going to be applied for potential issues or data loss. This is because using rollbacks is always associated with risks. The data changes constantly and there is the risk of data loss. Plus, there is the risk that the rollback is not going to be executed on all database instances. So there might be a database drift. Use this feature very, very carefully. There's also rollback to date to reverse the changes based on the date and time. Plus, there are some other useful categories that you can study in the documentation. You can actually perform rollbacks using Maven, and now we will see how to do that. So first, we need to configure Maven to be able to use the rollback goal with it. Head to the pom.xml, we need to add the new plugin, Liquibase Maven plugin. We also need to add some configuration. There are many possible adjustments. Again, you read the docs carefully and you configure the plugin for your project, but the most essential options is that you have to specify the changelog file, and here we are specifying the path to the master changelog. Also, we are going to specify the driver, which is PostgreSQL driver, and you can also specify the URL where the database is available. In our case, it's localhost 5432 Neurowatch, the username, the password for the database, and that's basically it. Now let's create another changelog with the test rollback. Let's add a change set with ID 005. You already know what preconditions are, so let's add a precondition. For instance, the database type PostgreSQL, and not to update the database if the column already exists. We're going to add the column to civilian. Let's call it temp nodes. Default value NA, non-applicable. Actually, it doesn't matter what we do, how we call it here, because we are going to delete it anyway. And now let's add another change type, which is a rollback. Here we are saying drop the column named temp nodes from the table name civilian. It means that in the case of something going wrong, we are going to drop the column. Okay, that's it. Run the application. You can go to the database tool to verify that the schema was indeed updated. We have a new column in civilian, and now we are going to execute the rollback. We have already configured the Maven plugin, so the command is pretty simple. We are going to roll back one file. You can specify other options, but we are just keeping it simple here, and the command is Maven Liquibase rollback. That's the goal, rollback, and then Liquibase rollback count, which is 1, so we want to roll back one file. Run the application again. In the console, you will see that the rollback was applied. You can check the schema again in the database tool, and you will see that the column has disappeared. Well, that was a very easy example. Again, I can't stress it enough. Always check the rollbacks and the impact that they may cause. Run the rollback SQL first before executing the actual rollback. Another interesting feature of Liquibase that I wanted to show you is Liquibase diff. It is a command in Liquibase that allows you to compare two versions of the database or two databases. The diff command is useful when you want to analyze and compare the changes that were made to the database since the previous version. This is a very cool feature that can be useful in several situations. For instance, when you want to use Liquibase with some existing project, this Liquibase diff file tells you how to recreate the state of the database. Plus, you can document changes that maybe some developers forgot to apply. But in some cases, diff may bring additional complexity to your workflow. The diff command may generate a changelog that is not perfect. It just can't be perfect because these files show the syntactic differences, but they don't understand what the changes are all about. So, for instance, if somebody changes the name of the column, the file tells you that there's a column that needs to be dropped and a new column that needs to be added. So, if you run this migration, you will lose the data from the previous column. If you want to use diff, always verify the files. You must be able to understand what's going on in these generated changelogs and adjust them manually. Also, you can use additional tools to validate the changes that might be applied. For instance, a JPA body plugin in IntelliJ IDEA. Alright, I warned you, and now let's see how we can use the diff command. First of all, we need to add a dependency to Hibernate to our pom.xml. We also need to add some additional configuration to the Liquibase plugin. As already said, the diff command compares two versions of the database. So you need to specify the version that you are comparing to. In our case, we already specified that it is a db changelog master. And next we're going to specify diff changelog file. This is going to be a file that will be generated automatically by Liquibase after database verification. You can name it as you wish. One useful approach is to use the timestamp in the name of the changelog. Also, we need to add the reference URL. I know it looks like a lot of code, but no worries. The link to the repo is in the description to this video, so you can go there and just copy-paste whatever you want and look at the code more closely. Right, so what is going on here in this reference URL? We are telling Hibernate that we are using the project in dev cyberjar, we are using PostgreSQL dialect, and we're also adding the physical naming strategy and the implicit naming strategy to Hibernate. After adding these configurations, you can run the following command: Maven clean install Liquibase diff. Clean install is important here because Liquibase diff uses compiled classes from the target directory for comparison. So in this case, you need to rebuild the project. You will see a huge log in the console, and then you will see that the diff command was completed and the file was generated. The file is indeed in the changelog directory. You can open it up and inspect it. Liquibase detected some changes that we introduced. Then you can add this file to the master changelog after you have verified that everything is okay with the change set and after you have introduced some manual updates if you need to. And then when you run the application, the changes from this changelog will be applied automatically. Again, I can't stress it enough, always check this file. You have to understand what's going on in the database. This is a very useful feature that helps you to create a changelog automatically so that you don't have to do it manually. But still, even if it helps you to gather data on the changes that were applied, you still have to review these files. That was about the diff command. And now I want to show you how to use Liquibase in CI/CD. You can use Liquibase in CI with GitHub Actions or Jenkins, for example. There are lots of GitHub Actions for Liquibase. So when you use Liquibase in CI, you run the migrations before deploying the application. And even better, you can perform the dry run of the Liquibase. This is a process of verifying the SQL that needs to be applied. If everything is okay, then migration is performed. And then, if the migrations run successfully, the application is deployed. So let's see how we can do that. The name of the file is Liquibase CI pipeline. It's going to be triggered when we push changes to the main branch of our application. And below are the jobs that we are going to run. The first one is to verify Liquibase. In this job, we are specifying the services that we need to spin up. In this case, that's the Postgres service. You specify the database user and password, and of course, you should use the secret GitHub tokens in password fields, but this one is just for simplicity's sake. Also specify the ports and necessary options for checking the health of the service. So we are going to continue with the migration only if the service is up and running. The next step is to check out the repository, and then we process resources with Maven process resources just in case. And then the interesting part starts here. So we validate changesets in the next job. We use the Liquibase GitHub Actions validate action. We are specifying the changelog file, which is our master YAML file. We also specify the URL, username, and password. And note that here in the URL, we are not saying localhost, we are specifying the name of the service that we have spun up, which is Postgres. After validating the change sets, the next job is to preview update SQL, which is the dry run of the migrations. And here you specify the same things, the changelog file, URL, username, password. In the next job, we preview Rollback SQL. So this is going to be the dry run of the last change set, and it's rollback. We are verifying that the rollbacks work as expected. Again, specify the name of the changelog file, the count of the change sets that we want to roll back, in this case it's 1, URL, username, password. And then you apply the Liquibase migration using the Liquibase GitHub Actions update action. So if all the previous jobs have run successfully, we are going to apply the migration. We are again pointing to the changelog file and all the other same parameters. After that, you run the test and then you deploy the app. This one here is just a placeholder. Deploy your app here because we're not going to actually deploy the app here. We just want to verify that this step will be completed if everything before was run successfully. Awesome! We learned how to introduce Liquibase into a Spring Boot project. Don't forget to like this video, leave a comment if you have any questions, subscribe, of course, and until next time!